struggling to work with big data in a variety of forms. One common type of big data is spatiotemporal event information. For example, this data set contains 1 billion financial transactions across the US. And the problem with this kind of data is that to visualize it, you have to wait, and wait, and wait, and see if it ever stops drawing. And you can't find patterns in information this way. To find meaning in these kinds of huge data sets, the first thing to do is a simple aggregation. So how did we aggregate 1 billion financial transactions? We've been working to enhance ArcGIS with capabilities for batch analysis on these kinds of huge data sets. Geoanalytics will be a new server capability that lets you run spatial analysis as distributed computations across a cluster of machines. The Geoanalytics tools are geared to help you understand your data. You'll be able to find hotspots, run buffers, and summarize your data to explore patterns. You'll be able to aggregate your data by regular bins, such as, in this case, we're looking at the raw count of transactions. Or you can run densities to see distributions in your data. In this case, we're looking at the density by the amount of money, so we can see which areas are associated with larger transactions. And you can also aggregate by any polygon, so that you can normalize by population and begin to understand where patterns are different than what you might expect. In this case, we aggregated the billion records by the 74,000 census tracts in the US. The Geoanalytics tools can operate across a cluster of machines, which means that you can run bigger jobs than ever before. Now, exploring patterns is an important first step in understanding your data. But in these mountains of information, often what you're looking for is a needle in the haystack, the activity that actually differs from the normal pattern. In the case of financial data, often what we're looking for is waste, fraud, and abuse. So what does fraud look like? Let's check out an example of how money laundering can play out in the real world. One technique that criminals use to move large sums of money around is to spread it out over multiple transactions. So one or maybe a few people will quickly visit several financial institutions and send transfers that are all below the legal reporting threshold. Some of you have domain expertise like this, but many of you want to understand the important and abnormal activity in your data. The challenge is how you query for that. How do you teach a system to detect that? If you were going to query for this money laundering behavior, for example, there's all kinds of variables. For each transaction, you'd have to consider the distance to nearby events, the amount of time between them, the amount of money involved, and then the recipients at the other end. And then you have to do it all 1 billion times. You'll be able to use the new tools in Geoanalytics to ask these kinds of complex space-time questions. For example, the Join Features tool lets you find associations between features based on attributes, based on spatial relationships like these, and based on temporal relationships, and all three of these at the same time. This is multiple dimensions of relationship analysis, and it's never been possible before at this level of space-time detail. We used Join Features to mine all 1 billion financial transactions for this fraudulent behavior. So let's see how that works. The Geoanalytics tools work with your data. You'll be able to use them with traditional geospatial formats, and you can also attach your big data to ArcGIS as file shares. Now, to query for this money laundering behavior, we focused on the starting locations of these transfers, and we joined them against themselves. So for every single transaction, we asked how many others took place within 1 kilometer and an hour of it that were all going to the same recipient. And the tools let you run summary statistics on any of your input fields. So we summarized the amount of money involved in each grouping and used that to refine the results. Using a cluster of 20 nodes, we ran this 1 billion feature join in 48 minutes. 48 minutes to burn down that haystack. Thank you. 48 minutes to burn down that haystack and find all of the potential needles within it. And what we're left with are just those bursts of activity from a small area that all went to the same recipient in a different location. And then we can use the amount of money and the number of transactions to isolate the most suspicious behavior. Geoanalytics will bring the power of distributed processing to your vector big data and open up new ways to examine your information across space, time, and signal for heightened understanding and awareness. The patterns and trends that you discover with these tools can then be automated to raise indications and even alerts when important activity happens. We can't wait to see how you apply these tools to the questions you never thought you could answer.